Hello everyone and welcome to the next contest of Leetcode, which is 475th one. Let's start with the first problem. So let's understand the problem. What this problem says is the problem is about the minimum distance between three equal elements. Let's understand the problem. They are saying that you are given an integer array nums. So you will be given an integer array nums like this, which will be 1, 2, 1, comma 1, comma 3. I have to consider a tuple of three elements of I, comma j, comma k of three distinct indices, and it is considered to be good if the nums of all these three indices is equal, means nums of I is equal to nums of j and is equal to nums of k, and the distance between a good tuple is considered to be the absolute difference between the I and j, and absolute difference between the j and k, and absolute difference between the k and I. That means this is a potential value for this good tuple. What is potential value is that it's the absolute difference between these indices, the sum of absolute difference between these indices. Okay. So we have to consider all such good tuples, and we have to calculate the potential values for all these good tuples, and we have to return the minimum value. We have to return the minimum possible distance that we can consider from these all potential values. Let's understand this problem. So I have taken the first test case where the elements are 1, comma 2, comma 1, comma 1, and comma 3. So I can see the one element present three times at indices I, comma j, comma k as 0, comma 2, comma 3. Means index 0, at index 0, at index 2, and at index 3, I can see the element 1 present here. So I can consider 0, comma 2, comma 3 as my potential good tuple. And I will calculate the potential value for this good tuple as absolute difference between 0 and 2, absolute difference between 2 and 3, and absolute difference between 0 and 3. So when I will calculate this value, I will get it as 6. So for the first test case, I am having only one good tuple and one potential value for it. So I am having the straight result as 6. That the output will be 6 here. Let's consider the second test case, this one. So when we will see this, we are having 1, comma 1, comma 2, comma 3, comma 2, comma 1, comma 2. So here I am having my potential elements as 1 and 2 because 1 has appeared 3 times, 3 or more than 3. Here I can see 3 times 1 appearing. One is appearing at 0, it is appearing at 1, it is appearing at 5. So the element value is 1. So you can see that the absolute difference between all the indices where 1 is appearing will be 10. It is calculated here. And similarly for 2, 2 is appearing at index 2, index 4, and index 6. So if we will calculate the potential value for the element 2, we will get it as 8. So as we are having here two good tuples, for two good tuples we can have two potential values corresponding to them, and from this we can have the minimum value as 8. That should be the output of our for this input. So here we can see that the output is 8. This is the problem, and let's go to the solution. What we can say is that here by some thinking about the problem, we can say that I can see that here I will need some mapping between the element. Like for one, I will need a mapping between one and the indexes or indices where one is appearing, so that I will get this tuple, and so that I can play with this tuple. Similarly, for the second array, I can say that I will need an element and the indexes and indices where this element is appearing. So similarly for here, I will need one and wherever one is appearing, and two and wherever two is appearing. So I can see the some sort of mapping is present here, right? So for mapping, we can start with using maps. Simply maps will solve our problem. So let's start by declaring a map. Now map will be between an integer value and a vector of indices where this element is appearing. So I will create a map, right? And now what I will do is that I will start creating our data structure. I will start filling the values in our data structure map. So what I will do is I will look for the element and I will push its index in the in an array, and I will have that array as a map to that element. So what I will do is I will create a for loop, and I will say that map one of nums of I dot push back I. That means for an element I am pushing its index, right? So what this will create for the first array, it will create like 1 will be at 0, 0, comma 2, comma 3. And for 2, it will be 1 because 2 is appearing at index 1. For 3, it will be 4. So this will be the output for this will be the data structure values for our first test case. So what's next? So we will have to calculate all the potential good tuples, whatever good tuples we are getting. So what we will do is that a good tuple will be for good tuple we will need three indices, right? I comma j comma k. So they should be at least three. They can be more than three as well. So I will try iterating on this map. Sorry. So in this map, I will check because I dot first will point to an element and I dot second will point to a vector, which will contain all the indices where that element is appearing. I will check if 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 I dot second dot size is greater than or equal to 3. That means the element is appearing 3 or more times because we will need minimum of 3 indices for it. So I will say that yes, it is appearing and we will calculate our potential value and potential or I can say the uh, good potential. Good potential initial I will consider it as int max. I will say it is maximum because we have to calculate the minimum answer. So I will initial value I will take a int max. Now I will say that this good potential must be minimum of the good potential, comma, some function, some function that will calculate the potential of this tuple for this good tuple. So here I will have to pass my arrays which will contain the indices of that element. So now I will have to check what this good function will be doing. So let me write this second good function. This will be taking an array, or I can say a tuple, more naming, good tuple, right? So it will take a good tuple. So what I have to do is now in this good tuple the elements can be three or more. So I want three elements at a time. So I will start with 0 and I will say that it should be less than good tuple dot size minus 2. Because let's say if I am having element as 3, comma 4, comma 5, comma 6, comma 7. These are the indices where a particular element is appearing. So initially I will consider these three elements. Then at the next I will consider these three elements. And at the next I will consider these three elements. So my I will go to 0, 1 and 2. My I won't go to 6. That is why I have done minus 2 here. So what I will do here, I will check the first index as I I1, that will be of good tuple of I. Second index will be at I plus 1 and the third index will be at I plus 2. So from all these three indexes, what we have to do is we have to calculate a potential value. We will calculate a potential value that will be a absolute of I1 minus I2 plus absolute of I2 minus I3 and plus absolute of I1 minus I3. Now we will just return this potential value. That's it. Not here. But this is a potential value calculated. Now there will be some more elements, some more tuples in this complete set of indices, right? So I have to calculate the final answer. I will mark it here as int max again. So I can say that my answer should be minimum of answer comma potential value calculated here, right? Because I want the minimum of potential value and I will return the answer from here. So what I can do is that I will get a good potential here as minimum of good potential, here this, and some function of I dot second. So with this, I will get my answer for the good tuple, and I will just return here good potential. Let's check by running the program if it works. So yes, so it worked for test case 1, it worked for test case 2, but it failed for test case 3 because it had returned the answer as int max. Why? Because size is less than 3, and size is less than 3, that means it is not going to process. But if we are getting answer as int max, then we shouldn't consider it, right? So what I'll do is, if this good potential we're having, its value is as int max, then return -1 because it said that if there is no good tuple, then return -1. So I will again run this. So I can see that the third test case is passed and now all the test cases are passed. Let's try submitting the problem solution. So we can see that the test case has passed. But can we optimize this more? Let's understand about the time complexity of this solution. So I can see that I am only creating a map that will store the mapping between the element and the indices where this element is appearing. And what I am doing is for this, what will the time complexity? For this, the time complexity will be big O of n, n times of log of n. Why? Because the outer loop is running from 0 to n. N is the number of elements in nums. And inside that we are pushing element in map. So for a single push, for single insertion in map, we need a time complexity of log n. And here we are iterating on map. And here we are having one function. So what I would say is for this complete function, we will be having the time complexity as big O of n. Why? Let's understand. Let's say that I am having only one element, right? Only one element, and I am having five times this element is coming five times, means my nums will be like this. So this is my nums. So what will be what? How will my map will look like? My map will look like this: one and uh, 0, comma 1, comma 2, comma 3, comma 5, 4, right? So if I am coming for the I'm coming in this loop, it will check for the first element, that is 1, and that for 1 it will iterate for all these elements only once, right? All these elements only once. That means I can say that it won't exceed big O of 1. Means if there is some more element as 2 here, 2 comma 2, let's say this. So what my array would look like, what my map would look like, map would look like this. It would look like 0, 1, 2, 3, 3, comma 4, comma 5. So now it will come to 1, it will iterate 0, 1, 2, it will go to 2, it will iterate 3, 4, 5. So can you see that all the elements of this nums are getting iterated only once? That means for this complete loop, my time complexity will be big O of n. So my complete time complexity here will be big O of n times of log of n and plus big O of n. This will be my time complexity, right, for this. And this is working. Can you optimize this more? Let's see. Here we are using an ordered map. Do we need ordered map here? Because we are not considering any order of element, like here, like in my this map. If this is my input, then if one is stored first or two is stored first, we don't care about it, right? We don't consider the order here. So let's try changing our map to unordered map. Let's see if this works. So this works. Let's try submitting it. So the problem is submitted. But so how is the time complexity affected? Because for insertion in an unordered map, we will need a time complexity of big O of 1. That means this. So here, our time complexity changes from big O of n log n plus big O of n to big O of n plus big O of n, which is better, which again gives us big O of n. So we have reduced our time complexity from big O of n log n to big O of n by use of unordered map. Or I can keep it just for understanding. So this is our solution for this question. And the second problem is a similar one. If I will use the same solution there, it will work because it's exactly similar one. Let's see this. This is the problem 2. Let's try using the same solution here as well. Second problem is a similar one, just the differences of the constraints. The constraints are more for the second problem than the first. I will explain why this works here. So see, this problem is working here. So for the second problem, what the problem says is it is exactly the same problem that was the first one. Just the difference is about the constraints. Here the nums dot length is 10 to the power 5. So what happens is now our CPU our CPU can only run 10 to the power 8 operations in 1 second. Means in 1 second you can only a CPU can only perform 10 to the power 8 cycles, right? So our expected time complexity should be 1 second. Our code should not take more than 1 second to execute. That is why the maximum operations that in 1 second the CPU can do is 10 to the power 8. Now what the constraint here is? It is that the nums dot length will be less than or equal to 10 to the power 5. Let's consider the upper limit. N will be equal to 10 to the power 5. That is the upper limit. And time complexity. Our time complexity is big O of n, right? So it will be maximum. It will be 10 to the power 5, right? Means that will be 10 to the power 5 cycles. That's easy. Means a CPU can execute 10 to the power 8 operations in 1 second. It can also execute 10 to the power 5 as well. So that is why it's working, right? That's why our solution is working here. And one thing I would like to show that see here the accepted time complexity is 502 milliseconds, right? With unordered map. Let's check with ordered map if it comes more. Means if it takes 502 milliseconds, right? Let's check with ordered map how much it takes. So as you can see, the time complexity increased. That means the time required by this execution of this solution is 719 milliseconds. That means the time taken by ordered map is more than the unordered map. Why? I have already told you the reason that while insertion in ordered map, the time complexity required is big O of log n. That was the overhead. But in the unordered map, it is big O of 1. So we are saving our time here. So that's why unordered map is better when we are not considering any order in the data structure, right? So this was about the first two problems, and in the coming video, I will be discussing about the third problem. Thank you. Keep watching, keep learning.